All right, so today we are going to talk about sets. Our main focus will be on three set problems, but we will make a quick review on two set problems, solve some questions, then move on to three set problems. Okay, so let me put the topic down. By the way, I'm using the Paint app to do the presentation. All right, so sets, that's what we'll be talking about today. So, a set is a well defined collection of objects of the same kind, and a set may be described by listing the members or defining a property of the set. So, let's say a set of A having members of natural numbers less than 5. So, either we list the members of A to describe the set, or we define a property of the set. So it's going to be natural numbers less than 5, 1, 2, 3, 4, for listing the members, and defining the property, we're going to put that in words. So A will be equal to natural numbers less than 5. Alright, so that's how we describe sets. Also, let's move on to the types of sets. We have finite set, a set whose last member can be found is a finite set. So when we check from our example from here, A having members of 1, 2, 3, and 4, the last member of set A is 4. So A becomes a finite set because the last member can be found over there. So any set having its last member known is known as a finite set. Also, for infinite set, a set whose last member cannot be found is an infinite set. And we use three dots to represent a set being infinite. So let's say set B having members of natural numbers. So it's going to be 1, 2, 3, 4, 5 is just infinite. So we add three dots to indicate that the set is an infinite set. We also have empty set. A set which has no member or element is called an empty set. So that one you just put a bracket and you're not going to put anything, any member or element in the bracket. So let's say a set B or a set C being an empty set is just going to be this, and you are done with that. We also have a unit set, a set which has only one member. So let's make example of that. Let's say set D having only one member of, let's say, 6. So set D becomes a unit set. We also have subset. So let's say a set A. The members of set A also belongs to set B. Then set A becomes a subset of set B. So let's say set B, a set of B having members of maybe natural numbers less than 5. Okay, so it's going to be 1, 2, 3, 4. And a set A having members of natural numbers, let's say less than 3, which is going to be 1 and 2. Okay, so A becomes a subset of B because all the members in A can also be found in set B. Also, there is a universal set. It's a set of all the objects under discussion, and it's been denoted by the symbol U. It's been represented by a rectangle in the Venn diagram. We also have equal sets. So two sets are said to be equal if they have the same members. So let's pick a set C having members of 1, 2, and 3. 1, 2, and 3. And a set D having members of, let's say, 2, 3, 1. Okay, 2, 3, 1. So all the members present at set C are also present at set D. So set C and set D are equal sets. Okay, so let's pick different sets. Okay, let's say set A having members of 1, 2, 3, and then let's say set B having members of, let's say, 2, 1, E, the letter E. Let me make it smaller. Okay, yeah, the letter E. And if your question is being given as A and B are equal and you have to find E, E is going to be 3 because A and B are equal sets and we can find 1 at both sides, 2 at both sets. So 3 should also be present at both sets. So the value of E will be 3 if only A and B are equal sets. We also have intersection of sets, a set of objects which belongs to a set, let's say A, and at the same time belonging to a different set, say B. It's said to be intersection of A and B. So let's pick another example here. Let's say set K, and the set K is having members of 1, 2, 3, 4, 5. And let's say a set of G, and the set G is also having members of, let's say, 1, 6, 7, 8. So if you are being asked to find the intersection of K and G, which is members of set K also present at set G, is going to be 1. So the intersection is members present at both sets being given, whether 2 or more. It can be 2 or 3 sets given at a time. Okay, that's the intersection of a set. Now to disjoint set. So if no member of a set, let's say A, belongs to a set B, then set A and set B are disjoint sets. So let's make that example also here. Set A having members of, let's say, 1, 2, 3, and set B having members of 4, 5, 6, 4, 5, 6, right? Yeah. So since no member of set A is present at set B, set A and set B becomes a disjoint set. We also have union of two sets. The union of two sets A and B is a set formed by putting the two sets all together. So let's pick the same example, set A having members of 1, 2, 3, and set B having members of 4, 5, 6. The union of A and B is going to be 1, 2, 3, 4, 5, 6. So A union B is going to be 1, 2, 3, 4, 5, 6. That's how we do find the union of a set. Now to complement of a set, let's say if a set A is a subset of the universal set U, and the complement of A is the set of members which belong to the universal set U but do not belong to set A. Okay, so let's make an example to that. Let's say a set on the universal set is having members of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And let's say a set of A having members of, let's say, 1, 2, 3. So set A2 is having members of 1, 2, 3. And you are being asked to find the complement of A, meaning all members present at a universal set, but we don't want the members of A. So 1, 2, 3 be excluded. So the complement of A is going to be 4, 5, and 6 as the answer. So that's how we do find the complement of a set. The union, the intersection, subset, when we talk about infinite, finite, and all those stuff. Okay, so now let's move on to the Venn diagram. Let me clear the screen so we can move on to the Venn diagram. Yeah. Let me draw the Venn diagram for two sets problems. I'll first pick a rectangle. going to be in the form of this. All right, and let me pick this from here and do that. Okay, I think this is cool. All right, second one, since there's two sets. All right, so the universal set U will be here. Number of U will be represented here. So number of U, which is a universal set, will be here. And let's say two sets given, let's say set A and set B. Okay, so the number of A will also be here. Number of A, and the number of B will also be here. Number of B will also be here. And now let me shade some part of it. Okay, let me go to the home and pick some colors from here. Let's say color blue. Okay, and here too, let's say yellow. And let's make here black. Okay, I don't know whether I've gotten a black color. Yeah. So from the two sets, the part which has been colored blue is the number of A only, meaning members of A who are only present at A and can never be found at B. And the yellow colored portion is the number of B only, meaning members present only at B and are never present at A. And the black shaded portion is the number of A intersection B, meaning members present at both A and B. That's the black shaded portion. So that's how we do represent two set problem on a Venn diagram. So I think now we have we've gotten some review about that. So we can then move on to our main topic of the day, the three set problem. So let me clear the space and draw the three set problem and give some explanation about that. So I'll first pick let me pick the rectangle. Let me draw the rectangle, something like this. Okay. Let me add this one, this stuff. Yeah. Okay, I think it's cool. Oh, let me send that to top a bit. Yeah. Let me start from here. All right. Let me start from here also. All right. And the third one, let me try and start from, let's see here. Okay, so let's say there are set A, B, and C. Let's represent it by just that. So there is going to be number of A. Here it is going to be number of B and number of C. And the universal set, which is U, will also be here, just as we did for the two set problems. All right. So now let's find the various portions and label them. Okay. Yeah. So the part, let me pick a color from here. Okay, so the yellow shaded portion is number of A only, meaning members present only in A. Okay, they are also present at the universal set, but comparing it to A, B, and C, members present only at A, and the black shaded portion is number of B only, meaning members present only at B. Also, the blue shaded portion is number of C only. Number of C only. So members present only at C. And let me pick another color here. Green shaded portion is Number of A intersection C. Number of A intersection C. The pink colored parties. Number of B intersection C. Number of B intersection C. The purple colored parties. Number of A intersection B. Number of A intersection B. And the red colored parties. Number of A intersection B intersection C. Meaning members present at A and at the same time present at B and at the same time present at C. Cool. So let me go over that again. So the yellow part is number of A only, the black part is number of B only, the blue part is number of C only, the green part is number of A intersection C, the pink part is number of B intersection C, the purple part is number of A intersection B, and the red part is number of A intersection B intersection C. So let's solve some questions about that, and I'm going to clear the screen. So I want to type the question, then I'll add solutions to it. So the question is, I'll just be listing the key points, and I'm not going to write everything down. Okay, yeah. A science seat form in a school has 12 teachers. Of these, 6 teach mathematics, 5 teach physics, and 4 teach chemistry. 2 teach mathematics and physics, but no one teaches both mathematics and chemistry. Draw a Venn diagram to illustrate the given information. Find the number of teachers who teach chemistry and physics, and only physics. So now let's list the various data from the information given. So the universal set U is going to be total number of teachers. And from the question, the total number of science teachers was 12. So the universal set U is going to be 12. All right. And the question also said 6 teaches mathematics. So number of teachers for maths, let's represent that as M, okay? So M will be equal to 6. And also it says 5 teach physics. So let's represent that as P for physics being 5, okay? And from the question again, 4 teach chemistry. Let's represent that by C. So it's going to be 4 for C. Okay, and from the question again, it says 2 teach mathematics and physics, but no one teach both mathematics and chemistry. So let's draw that on a Venn diagram. Let me pick the rectangles and start to represent that. Okay, let me draw that here. It's going to be something like this. All right. Let me pick this one too. Start from here. I think it's cool. Okay, start from here. I think this one too is all right. Let's start from somewhere like here. And okay, oh, I think this two is fine. So the universal set U will be represented here, okay, which is, let me pick a different color for the writings, which can be clear. Let's say blue, okay, yeah. So number of U, which is the universal set, is 12. So number of U equals 12. Also, number of M, which is mathematics, is 6. So number of M equal to 6. Also, number of P for physics is 5. So number of P will be equal to 5. Also, number of C for chemistry is 4. So number of C will be equal to 4. And by the way, you can pause the video and solve the question. After that, you can check the solution out. Okay, you can pause the video and try the question for yourself before you check the solution out. So I want to represent the information on the Venn diagram. Then you can just solve the question and check the solution out. So from the question, it's we've labeled those part, okay, and it says to teach mathematics and physics. So that one too will be here. And the question again says, but no one teach both mathematics and chemistry. So meaning mathematics intersection chemistry will be 0. And since no one is teaching mathematics and teaching chemistry, meaning no one will teach mathematics and at the same time teach chemistry and at the same time teach physics. So number of mathematics intersection physics intersection chemistry, so is going to be 0. Okay. Yeah. So let's represent the P intersection C by, let's say, X. Okay. Yeah, let's represent just by a letter X, and we are going to find X as we've been doing in mathematics. So if here is X, then number of P only is going to be 3 minus X, and number of chemistry only is going to be 4 minus X, and number of mathematics only is going to be 4. How do we find that? Okay, so when we pick a circle or the sphere, let's say all these parts, when you add everything here, it should sum up to the one at the top here. Okay, so when you add all everything here, it should sum up to the one at the top here. When you add everything here, it should sum up to this one. Okay, so due to that, we can say which m, which is 6. So 6 is equal to, let's represent here by, let's see letters first before we solve them. So let's say here is A, okay, here is B, and here too is C. So for the first one, mathematics being 6 is going to be 6 is equal to A plus 2 plus 0 plus 0. Okay, it's just 0 plus 0 is 0. So 6 is equal to A plus 2. So A is 4, right? So we can say A is equal to 4. And let's find out of B. Now on to 5. You said everything here must sum up to 5. So 5 gives B plus 2 plus X. Okay, yeah. So B will be equal to 3 minus X. So let me put that one here. Be equal to 3 minus X. Now let's find out of C. Which one? That one too is 4 being equal to C plus X plus 0 plus 0. So C will be equal to 4 minus X. 4 minus X will be equal to C, right? Okay, so that's the Venn diagram. We represent the information on the Venn diagram. We find number of A only. We find number of M only, which is mathematics only, physics only, which is this one, chemistry only. Intersection of maths and chemistry was 0. All the intersection is 0. And intersection for maths and physics 2 is 0. Maths and physics is 2, okay, and that of this one is X, and we find everything. So we can add everything there, equate it to 12 to find the value of X, which is P intersection C. They ask that to find P intersection C, which is X. So everything in this region must sum up to the universal set. Okay, so it's going to be 4 finding the value of x. So it must sum up to 12. So 12 being equal to 4 plus 2 plus 3 minus x plus x. Let me extend this one so it can cover those space. Okay, so 3 minus x plus x plus 4 minus x plus 0 plus 0. Okay, let me just write that 0 obviously. So 4 plus 2 is 6. 6 plus 3 is 9. 9 plus 4 is 13. And plus 0 plus 0 2 remains 0. So we have negative 2x plus x is going to be negative x, right? So we can say 12, 12, which is the universal set, okay, is equal to 13 minus x, okay, and x is going to be 1. X is 1. So we just send x here and bring that 12 here. 13 minus 12 is 1. So x is 1. So the value of P and Q is 1, which is x, okay. We've been able to find that one. And the question also asks us to find teachers who teaches only physics. And those who teach only physics is this part, which is B, 3 minus x, and x is 1. So 3 minus 1 is going to be 2. So those who teach only physics 2 is going to be 2. There are a lot of questions. Just revise on this. If you don't understand anything, or you can DM me with it, then I will explain it to you. So let's end today's lesson. We will continue for mathematics next week. Thank you all.